Hola. Hola chicos y bienvenidos a todos al track 2. Ahora vamos a tener la charla de Orestes que nos va a hablar de cómo integrar proyectos de Google. veo que a todos os interesa. Así que bueno, un aplauso para él y bienvenidos.
Hello, can you hear me okay? Oops. Okay, so this talk is going to be in English. I got to get better, you got to get used to it, so let's do this. We're going to talk about the IoT integration that we have in the Google Assistant API. There's an API, it's called the Smart Home API. It's really cool, it's really useful. Not a lot of people use it, and I brought a demo here I wanted to share with you guys. So first of all, thank you for coming to my talk. I want to say thank you also to T3chFest, to all the organizers, all the volunteers, and also all the sponsors. It's freaking incredible that we have such a big event for free. I'm astounded. So great job. Thank you for inviting me. This is the mandatory ego slide. My name is Orestes. I've been coding for a long time. I started being paid when I was in 2005. And I'm a full stack developer, and I'm a huge metalhead. I'm a community lead, a mentor, author, and right here is my Twitter. Feel free. We're gonna have a time to ask questions later, but if you're not comfortable asking questions, you might ask me on Twitter later, or you might come to me in person. You can also use my Twitter to follow me and to send me pictures of cats, which I love. Here's mine. It's super cute. This picture is taken where I live in Galicia, which is northwest Spain. I live in Pontevedra, which is near the south, close to Portugal. And we have a lot of cool things in Galicia. One of the coolest things that we have is we have a community cluster named Vigo Tech Alliance. And you probably heard of it if you live in Spain. We make a lot of noise. We make a point of it. Basically, a community cluster is something that a lot of people have thought about before. We aggregated all the different meetups that we have in the city, and we put a common calendar, so you just go to the website and you know what's up. A lot of people have tried to do this, and I mean, it's not that hard. You can fork the repository and try if you want to do it in your city. There's other cities like here in Madrid, Copenhagen, La Rioja. There's a lot of places that are doing this, so you're welcome to try this. This is the activity for this month. That's a lot for such a small city. We're super proud of that. And part of the Vigo Tech Cluster is GDG Vigo. I'm repping GDG Vigo. GDG Vigo is the chapter for Vigo, for the Google developer groups, which is a very big initiative. There's a lot of Google developer groups here in Spain. I don't think there's like even half of the people in here. There's people in the room that are in this picture. So if you don't know the Google developer groups, this is an initiative led by Google to provide people with opportunity and connection to get better at technology, to get started with technology. And it is a global program. It is a really big program. We have like 800 chapters all around the world, and we're super proud of that. So reach around if you're watching on streaming, Google us. There's probably a GDG close to you. And besides doing community stuff, I also need to work. And obviously, even though I live here in Spain, I work for a company that I have in the US. I'm a co-founder of Lighthorse Consulting. We're an ice cream shop. Now, this is obviously a software consulting firm. And we do work for clients, mostly in the US. And we work with projects that have a lot of data, a lot of interesting data. We've worked with public administrations like the Pennsylvania System for Higher Education. We've worked in projects with data from the Department of Defense budget, and we analyze where that budget is going on a per region basis, and we have like visualizations of what happens if they cut a certain part of the defense budget or they increase something for a different sector, and how many jobs are gained or lost through those changes. So those projects are really interesting. I'm really proud of working in this company. And this company was started like 3 years ago. And a little after that, we started another project that was just a product company. And this company is named Navigo. And Navigo has a mission, which is to track people that are traveling abroad. They're in different countries, potentially dangerous countries where there's civil unrest, where there's political instability, and they're probably doing like a humanitarian mission, a relief mission, and we provide tools to track them where they are and to let them know if something dangerous is happening close to them, and we warn them, and we have like a rescue system and a secure channel of communication with them. So this is a really cool project. I'm really happy to be working here. But the general use case, I feel like could use a little bit more empathy. So let's say that you have somebody, a relative, your significant other, your brother, that is traveling abroad and is going to be away for a couple of weeks. He doesn't have very good internet communication, and you can go on the website and check how that person is doing. And that's cool, but you gotta use the website, you gotta log in, you gotta do, we are lazy. It will be much better if you could use one of these devices and say, hey, I'm not gonna say it because otherwise every Google device is gonna pop up, hey, how's my brother, or how's my wife, and they could tell you, yeah, your wife is at the hotel, she's been there for a few hours, her phone is fully charged, there's no danger nearby. Like, that's super quick, super snappy. So experimenting with these kinds of interactions, that's how I started working a couple of years ago with voice user interfaces, and I got hooked. Like, it's super fun to talk to a computer, talk to a device. We've always wanted to do that. And the thing is, this is like Pokemons. You get one of these, then they came up with another one. There's another one with the screen. Like, this is fun for ages. This is really cool. Those devices are all these devices are just dedicated for communication with the Google Assistant. But there's other ways that you can communicate with the Google Assistant even if you don't have one of those. You can use it on your smartwatch. You can use it on your phone. Even if you have an iOS device, you can just download the Google Assistant app. And now there's cars that come with the Google Assistant integrated. It's freaking amazing. So there's a lot of places that you can interact with the Google Assistant. And now there's a lot of devices that the Google Assistant can integrate with. Like, this picture was taken on last Google I/O. I'm pretty sure the number is probably doubled by now. And that's what we're going to talk about, how those devices work and how you can build your own. So after I purchased my Google Home and then my Google Home Mini, and then I said, okay, I'm not going to buy the other one, I bought one of these. And I thought these were super cool. This is a smart light bulb. And it's just a light bulb that has a Wi-Fi connection. And you can control it with your voice and change the colors and turn it off and on again. I mean, it was super cool. And I thought, how is this working? Like, I want to know. I want to build one of these. So that's what we're going to do here today. We're going to build our own smart light bulb. I mean, it's going to be super tiny. And since I couldn't bring my home, I brought this small Lego home. And we're going to put the light bulb right there. So that's what we're going to do today. And first of all, probably a lot of people here are familiar already with IoT, but I'm going to give a really, really brief intro about what IoT is and how it could benefit you as a developer. Then we're going to talk a little bit about Actions in Google and how it works as a platform. Really, really tiny bit. Even if you're familiar, you can probably use it. And then we're going to actually walk through how to set up this project in the Actions in Google console. And then we're going to do a demo. And 5 minutes ago, it worked. So fingers crossed, it'll work again. So the Internet of Things, this thing is everywhere. And basically, the Internet of Things is the next paradigm shift in computation. We used to have really big computers, really expensive computers, really power hungry. Then it came the personal computer, where access to computers got democratized and everybody had one at home. Then came the Internet, and it connected us all together. That was amazing. Now we are in an era where the Internet is available pretty much everywhere. It's pretty cheap in most of the world, and computing devices are getting even smaller and even more efficient. So now it's possible to have thousands, hundreds of thousands, hundreds of millions of devices that are interacting with each other and doing very small computations, gathering data, and acting like a big cloud, like a big intelligence made of small, cheap devices that you can replace very easily. So that's pretty much what the IoT is. And as a developer, I thought, I want to get in on that. So a few years ago, I bought a kit with Arduino, and I bought a book. And I built this Knight Rider visualization. I was super proud. Like, that was a few years ago. I was like, I feel like Michael Knight. Like, that was incredible. I sent it to my dad on the phone. I was like, look what I did. And he was like, well, call me when it talks. So he was like, okay. Now we can do it. Anyhow, you can have a lot of fun building things that are really useful, like this robot that you can use to argue with people on the internet. That was a super thoughtful commentary. This video is by Simone Jets, who is a great YouTuber, a great maker. You should probably follow her if you enjoy this kind of stuff. But besides being fun and being a creative outlet as a developer, it ended up being, for me, a skill that applied to my regular job. So a few years ago, I was working in Barcelona. I was working at a digital signage company. Basically, what we did is, if you have a screen somewhere, we find a way to play content, to schedule content, to run ad campaigns, all kinds of things. And we work with really big brands. And one of the things that we did is that thing on the right, that is a kiosk that is meant to help citizens in Barcelona. If you don't want to go to the town hall, you can do some paperwork here with just your ID card. The project was really cool. That was built by my company. We had a slight problem, though. There's this thing right here. We don't really see it very well in the projector, but that's a document reader. You put your ID in there, you can put your passport, and it can detect fakes. It's a really amazing piece of technology. Obviously, you need to authenticate to do some of these paperwork. And we had an issue with people using the kiosk. It will come a point where the kiosk will say, okay, insert your ID card now, and they will find a gap between the reader and the metal and jam the ID card there and just wait, or maybe on the side, or maybe on some of the other all the other slits, and that was not the purpose. And then they got frustrated. It doesn't work. It took my ID card. Well, it was all kinds of painful. So my company came up with the solution to put a LED strip around here, and when the time came to scan your documentation, it will flash like you were at the airport. Here, put your ID card here. Flash really intensely. There's no way that you miss it. The problem, though, was that if you ever worked on one of these machines, like this one, for example, at IKEA, that we also built a few years later, you know that what's in there, it's actually a website. And it's actually running in Internet Explorer. And now we have web USB, and we can access the USB, and we can do stuff with electronics from the web. But a few years ago, that was impossible. The thing is, since I knew a little bit about the web, and that was my job, and I have been tinkering with electronics, I found a way to build an ActiveX controller that opened the COM port and control a USB board relay, and that will turn on and off the LEDs. And that was done all with JavaScript. I'm not going to play the video, but you can tell that's HTML, and if you use that, it will basically turn the lights on and off. And I thought that was incredible. We saved the project from the silly users that got confused, and I got to use some of the electronic skills that I acquired. Probably not all the cases are going to be that extreme, but I found it really, really, really fun. And when I started, you had to buy an Arduino kit. There was pretty much no other alternative. They were kind of pricey. They were kind of big. Nowadays, you can buy one of these things that my friend Santi, who's right there in the audience, introduced me to. Hey, Santi, a few years ago. And it was mind-blown. This thing has a lot more features than my old Arduino Uno. And it costs €3. Like, it's super tiny as well. And it has like even a built-in Wi-Fi module. Here you can see the antenna. Like, this thing is incredible. And if you buy them really for cheap in AliExpress, like, you can get them for like $3 a pop. So we're going to be using one of those to be the brain of our smart light bulb today. And another really recent discovery was these lights. Do you guys know these ones? The Adafruit NeoPixels. These things are incredible. If you ever program an RGB LED, you have to pass the different colors to the different values to the different pins and do the mix of colors. This thing does pretty much all of that on its own. And you can chain them together. They're really cheap and they're really cool. And we're going to be using one of those today as well. So in the end, we're going to be using these libraries right here and these components right here. And the source code has been already published. This is how it looks. Like, this is a silly breadboard. You don't even have to solder. It's really easy to do it. If you want to do it yourself, here's the Arduino code that's going to power this demo. And since I'm a developer, I like to think in systems, and I like to have a black box here, a black box there, end-to-end tests over here. So what I've done is this thing talks HTTP. I can have it connect to a Wi-Fi, and I can make an HTTP request with JSON, and I can specify the different colors, the intensity, or to power off and on. I mean, it's really useful. And it is really useful because then you can encapsulate this and add more APIs on top, and you can call this from a website if you want it, like a web app or a PWA, or you can do what we're going to do, which is hook it up to the Google Assistant. So that was IoT. That was quick, I think. Now let's talk about Actions in Google. So Actions in Google is pretty much the operating system where the Google Assistant applications run. The Google Assistant applications that you build are called Actions, and the Google Assistant is the actual voice that you use, the actual interaction, and the one that helps you, talk to other apps and gives you the time and tells you when you have the next alarm and stuff like that. And it works. You can build apps for that, and typical app, it has a name and it has an invocation. This app, for example, is called FlipFlop. And it doesn't exist anymore. It used to be a demo. It's gone. But the idea was that you could say, hey, can I wear flip-flops today in this city? And it will reply, oh, no, it's too cold for flip-flops in Madrid. You should probably wear something else. And it was pretty easy. I mean, if you were... that scared me, sorry. If you were going to look at how it works behind the scenes, basically the Google Assistant takes your voice, turns it into text, runs some fancy machine learning algorithms on top of it, and figures out of all the applications that it has in the index, which one is the one that you want to talk to. And then it tells that application, hey, there's a user here for you. They want to talk to you, and they tell you, I'm going to connect you with this application right now. And from that point on, you're actually talking to that app. It is really easy to to use. So here you can see there's a couple of bold words. These are what we call intents and entities. An intent is just a user trying to do one thing, and an entity is a piece of information that is probably going to change from request to request. In the case that I'm trying to figure out if I should wear flip-flops today or not, well, there's only one intent. I can't really think of any other intents for this kind of app. And there's only one entity, which is which city are you interested in. So that is pretty easy to model. If you were going to use like Diaflow or any other tool to do chatbots, that is only a couple of, I don't know, a couple of hours maybe if you try really hard. But the thing is, what we're trying to do is not that simple. A light bulb has more intents, and it also has more entities. You care about the mode of the light bulb, if it's on or off. You care about the color, you care about the brightness, about the intensity. And if you start doing this for all the devices that you have at home or all the devices that you might build with IoT, you're going to end up building a lot of very, very specific applications, very specific actions that are only going to work for your use case with the Google Assistant. So you don't really need to do that work. You don't really need to think about all the different ways that a user can invoke your app. There's an API for that, and that's the Smart Home API. So the Smart Home API basically already knows about pretty much all the standard devices and traits, and it groups them together. So for example, you have a trait of brightness. An object might have a brightness setting. It might have a power setting or on or off, a color setting, like for about light bulb. And then you have device types that already include those traits, like a light probably has on and off at least, and probably has also brightness. And if it's a really smart light bulb, it probably also has a color setting so you can change it. So you don't need to really program all of these phrases in all of these different ways that you can invoke these different devices. Like, for example, hey, set the light color to red, or turn the temperature up, or set the temperature to a specific setting. You don't need to do that. The Google Assistant already knows how to do that, and it's a standard feature. It also knows how to do that with the UI. So I think I messed up. Sorry. It also knows how to do that with the UI. So for every kind of device, the Google Assistant and the Google app, if you're using it on in a surface that has a screen, you can see touch colors, and you can see like a color picker or a radio picker if you want to choose different intensities. It is really useful. You don't have to build an Android app for that. You don't have to build an iOS app for that. You can just use what Google gives you. And that's really, really useful. So Google needs to know for you as a user, when you talk to it, how many devices you have, what kinds of devices do you have, and how to connect with them. And the way it does it is if you have these devices here in your app, Google has a thing called the home graph, where it stores all of your devices and the current state. So if you change something, that home graph data needs to be updated. So how do you get data in there so that Google knows about your devices? The way that you interact with Google, with the Google Actions API in this case, is you talk to Google, you ask an invocation that is directed to a device, and then the Actions on Google platform does the same thing as before, but it recognizes that this is directed to a device. It matches that intent that it just recognized with your home graph information, so it knows if you ask to turn off the light, it knows how many lights you have. It knows, for example, if you are in the living room and the Google Assistant that you're talking to knows that it is in the living room, it'll turn on or off the light in the living room because it has a concept about room. And when it knows what it wants to do with which device, it sends that information in an API request to an API provided by the device manufacturer. And in this case, we are going to be the device manufacturers. We're going to provide the API. And they call this API the Smart Home Provider. So I've built a smart home provider using Nest, which is a really easy TypeScript framework to build backend applications and APIs. And the thing is, yeah, okay, you have an API and you have a database, but you have to get data inside of that database somehow, so you probably need an interface. And if you've ever bought a light bulb, you usually have to go to the manufacturer's website to set it up and say, hey, I bought this light bulb, set it up this way. So for that, I built a provider UI, which is just built with Angular and Firebase. So just to recap, we have two pieces here. The first one is the Smart Provider API, and that piece needs to interact with Google. It needs to comply with the OAuth protocol. It needs to understand how Google can authenticate with it. Then it's going to take care of intent handling. And these intents are not the same ones that you will do in Dialogflow. These are not necessarily the user intents. These are intents from the Smart Home API. These intents are slightly different, and they refer to specific actions like execute a command, or tell me how many devices you have, or tell me about the state of a specific device. And then it should be in charge of doing proactive updates, meaning if you have like a light switch that you can turn on off with your voice or with the app, and you go and physically touch that light switch and turn it on or off, you have to tell the Google Smart Home API, hey, this light switch changed. Otherwise, when the user goes to the app, that state, that UI for that switch is going to be inconsistent. So you have to do that. And then the Smart Home Provider UI, it needs to do just a couple of things. The first one is obviously it needs to do device management. It needs to let you add devices, remove devices, change labels, whatever. And it also needs to do user authentication and registration. And when you talk to Google, you actually end up going to a UI where you need to say, okay, this user has been now logged in, go back to the Smart Home API. So there's a few intents that you're going to get when you connect with the Google Assistant. You're going to get a sync intent, which is basically Google asking you for all the devices for the user. You're going to get a query for a specific device. Hey, tell me what's up with this light or with this fan. What's the state for this device? And this usually happens when you open the app and you're looking at the UI for a specific device. And you're going to also get execute. That happens when a user tells you to switch a light on or off, or turn up the fan, or do whatever. When you are acting on a device, you get these intents. And then when a user disconnects their app, you get a disconnect event for each of the devices. So there's a couple of things if you ever build an API that interacts with Dialogflow or any other platform that ends up doing actions on Google. The requests that you get, they are slightly different. They all have this same format. They are encapsulated like this, and there's no user authentication provided. You probably are used to getting the user information along with the request. Hey, I'm user of this. This doesn't happen. When you do the authentication, you have to keep track of which user you authenticated for that token that you gave Google. So just to recap, when you get one of these requests in your API, you're going to have to accept the HTTP connection, figure out which command you were issued, execute whatever command it was on the devices that you know about, and then reply with the result. And you have to be kind of quick about it. If you take a little bit of time, the system is going to say, oh, something went wrong. You're probably used to that. So, OK, with all of that, let's see it in action. Let's create a project. Anybody here has used the actions in Google Console before? Have you ever created an action? Can you raise your hand? OK, a few people. OK, so you're pretty familiar with this interface then. So you create a project, you give it a name, and then you have a few templates here. And here in Home Control, you actually have just a single template that you can use, which is the Smart Home project. And this project is slightly different. You usually, in this screen right here, you provide a name that the user is going to use to refer to your app and do the invocation. In this case, nobody's going to say this out loud. This is just going to pop up on the list of cloud providers or smart home providers. So you can put whatever in here. And then if you ever use Dialogflow, for example, you're used to seeing this screen with all the different actions that you can have a lot of actions, one per each intent. In this case, you only get one. And if you ever used this before, you see that this column right here usually says that the fulfillment tool is Dialogflow. In this case, you only get one action, and the fulfillment tool is the actions console. So that is different. The next thing that you have to do is provide an endpoint for the API, and Google is going to connect to this API. I have the URL here because it cut, and it's going to send all of the intent requests to the same endpoint. It doesn't make any distinctions. You have the information in the JSON to know about which command it is, but all requests go to this endpoint. And then you have to set up the account linking, the authentication. Right now, maybe this changed, but you can use OAuth. There's no implicit authentication, as far as I know, for the actions in Google. And basically, you give Google the client secret, and you're good to go. And Google will use that to connect to your API. And you have to provide it with a token URL that Google is going to use to get that OAuth token on behalf of the user. And you also have to provide with a UI URL, and that is the UI URL where the user is going to be redirected to when they try to link the device in Google. And we're going to see this live in just a moment. So just to recap, the API has 3 endpoints. Only 2 of them are mandatory, the one that gives you the token, the one that reacts to the API request from the Google Smart Home API. And then I had a little extra there. I put the login in there because if I ever change the direction, well, the URL of the front end, I don't want to have to go back here. So the API just redirects to whatever the UI is today. So this is what it looks like in a mobile phone. If you ever added a device, this is probably familiar. You start on a screen where you see your home, because the Google app, the Google Home has a concept of different homes, and you can have different devices in different homes. I have a home right here. It's called Toy Home. It doesn't have any devices right now. So if you go to Add Devices, and then you go to Device that works with Google, again, since you're using the same account on your Google Home app as you use in the Actions in Google Console, you get this magic link with the cloud icon and this tag here that says, this is in test. And that is your API. The moment you click that, you're going to get requests on your API. So this is a little bit of an overview of the process that happens when you click that link. This right here is the list that you're going to be added when you create your action in Google. This happens in whatever device that you're using. And then this is the UI part. This is the part where you have to take the token, the code that Google has initially, and you have to exchange it for an authentication for an actual user. So when you get done, you redirect to the URL that Google gave you initially. This is OAuth 101. It's pretty familiar if you used it before. And if not, in the docs, it's not very well explained, but there's other tutorials that explain it. And right after you redirect to Google, Google is going to send you the first intent. It's going to send you a sync intent, which is asking, okay, this user just authenticated in this platform. Now give me all the devices and the state for these devices for this user. And now you just reply. So again, just remember that every request that you get is going to use just the Google token. You are responsible for linking that when you log in the user with whatever user ID you're going to be using. And all the requests from then on, you have to just calculate, go to the database, go to your caching, go to whatever. So this is what it looks in action. And again, the code for this is provided in links at the end. And we're going to see this in a moment in a live demo. So initially, when you go to that UI, I have a little bit of debugging in there, so I know which query parameters have been passed to the URL, and you can see like a unique token that Google uses to identify that session and where do you need to redirect that. So then after that, I'm just using Firebase to provide authentication using my Google account. And when I get back to the client app, which again, I'm going to share the source code, I'm just redirecting to the URL that Google told me in the beginning. And then the app comes back on the screen, and magically you get the list of devices that you replied in the API. And we're going to see how that looks in a second. So when you get this request, you are responsible for giving Google back the list of devices, but you can do a couple of extra things. You can actually tell per each device, you can give it a room hint. If perhaps in UI you have a way, so when you set up your light bulb, you tell it in which room it is. You can relay that information to Google, and if Google has a room like that, named like that or similar, it'll actually place the device already there. If not, it's going to ask you to move it. So this is what a sync request looks like. When you get it for the first time, it's pretty simple, and this is what I reply back. This is just one light bulb, and as you can see, I'm using the type light, and I'm using those 3 traits that I mentioned before. And I'm also telling it that this light bulb in particular is using RGB. You can use different modes. You can actually use temperature, and you can specify a maximum and a minimum. It's pretty flexible. So again, after that, you got to remember, a user has to have an account in your system again, and it has to have a list of devices. They don't get created magically. They need to tell you about them first. Google sends you this sync request, and from that point on, Google knows about them and will present them in the API, in the app screen. So from then on, you're ready to accept any commands that the user runs. If they say one of these keywords, if they execute one of these intents, or if they use one of the screens, you're going to get an execute event intent. And we're going to see in a second how that looks like. So this is pretty familiar. Again, when you talk, it gets converted to text, it gets recognized, it gets analyzed, it gets put through the smart home API, it knows about which device you're talking about, or it guesses which device you're talking about, and then you get an intent. You get an HTTP post request that you can react to. And when you get that HTTP request, you are responsible for talking to your device. And you can do that however you like. I'm doing it with HTTP because it's easy to test, but you can do it with MQTT. There's people that do this with Firebase, like write to Firebase, and this device is actually reading from Firebase as well. So again, you can do it however you like. When you get one of these execute requests, it looks like this. You get a command, and these commands are pretty well documented. Again, there's links to the documentation. In this case, it's telling me to set the brightness for this light bulb to 97. So I'm responsible for knowing in my system, in my weird API that I've made up, how do I tell my light bulb to set the brightness to 97? And after I'm done that, well, I need to communicate what happened with that specific request. And per each one of the devices, you might get more than one command from more than one device, especially if you're doing something like routines and grouping commands. That can happen. And you're responsible for telling it that this was successful, or maybe the device was offline, or maybe there was an error because somebody passed a param that was invalid, or something like that. You are responsible for that. So here comes the demo time. This is the scary part. Let me switch. Let me switch to this other screen, and hopefully you should be able to see my phone here. Okay. Okay, so this is what we saw before. I'm going to tell it to add a new device. And I'm going to tell it that this is something that already works with Google. So I'm going to use the provider ID that I that I used initially. And I'm going to get redirected. That is my UI, directing me back to the application. And if everything goes okay, fingers crossed, come on. There we go. That's the one light bulb that we have in this system. So far it worked. Google knows about this light bulb that we have right here. And just to show you how this is working, this is the Nest API that's running right here. And I just have a tunnel running here with ngrok. And we're going to talk about this as well. Okay, so like I said before, since I didn't tell it which room I thought this device was about, Google is asking me about it. So I'm going to tell it it's in this home, in the Toy home, and it's in a room called downstairs. I don't have any other rooms. Okay, device was moved. Okay, fingers crossed now. Hey, turn the light bulb on. Drum roll, please.
Got it. Turning on the RGB.
Okay, so as you can see, I have a pretty cool UI. I just powered it off. It takes a second. It'll make a couple of requests, and it's off. It's really, somebody name a color. A weird one. Blue? Teal. That's a good one. Set the light bulb to teal.
Here's a matching video.
Oh no! Set the light to teal. Now I got it. It's thinking about it.
Changing the RGB LED 1 to teal.
Did it change already? I can't see it. Maybe it's off. Did we? I turned it off. I turned it off before. It's okay. Hey Google, turn the light on. Come on. The internet's a little bit slow, but there you go. That's teal. So in the Arduino code that I put there, I'm just saving which color and if the light bulb is on or off. So it's a pretty simple code, but you can do really cool stuff. Okay, so that was it. Again, just to reiterate, there are a few things that are slightly different with this API. When something happens, there are specific error codes that you need to use. Take a look at this documentation. Sometimes Google is a little bit particular about how it interacts with your error. So again, read the documentation a little bit. You can also get intents for queries. For example, if I open the log for the API, this right here is the log for the API. If I switch here and I go back to the screen, right there, here we can see that the Google API is actually making a query, and it's asking me for this light bulb. It's asking, hey, how's this light bulb? And I'm just lying, I'm telling it that it's using a different color because this is a demo. But it is asking when you open the specific screen, it tries to get the most updated state for the device. So these queries are really useful and they're really easy to respond to. You get a request like this and you respond with exactly the same as before, the definition for the device. And you have to reply with all the attributes. You can just say, oh, the brightness is set to this. You need to actually tell it about all the attributes. Okay, so those are kind of the reactive requests that you need to handle. But there's a couple of other requests that you can make on your own. You can be proactive and tell Google about changes in the environment. So first of all, you can tell Google, hey, something might have changed. Maybe the user went to the UI and added 20 new light bulbs or whatever, and you gotta tell Google, hey, maybe make another of those sync requests because I have new data for you. And Google will do that. You just make a post to this URL, you need to have an API key. You need to have an API key for that project, and you can make a simple, a simple call, and Google will actually send you another intent to your API. Another proactive request that you can make is you can report on state on specific devices. And this is actually really important. Google actually only stores data according to the documentation in the home graph whenever you are reporting state proactively. You do that on this other endpoint, and the thing is the security for this one is slightly different. Oops, I'm missing a slide. This one needs a different authentication. You need to have a service account, and you need to actually have a token and sign in. It's a little bit more involved, but the documentation is pretty good. You can understand it pretty easily. And the Google Docs say that you need to report state pretty much every time the user does an interaction, like I mentioned before. Maybe that light bulb had a switch, and I just turned it off. I need to tell Google, hey, report state, this device is now off. I need to tell it that, otherwise when it goes to the UI, that is going to be inconsistent. And then, which is kind of weird, but I get, those are the rules. Every time you get a single request or a query request or an execute request, you need to also report state, which is, you just asked me for something, I already told you it was okay, or this was the state of the device, but they want you to proactively tell them what is the state of the device. And keep in mind, again, for the execute, you need to actually tell it about the entire device. If somebody changes the brightness or the color, you can't report back, that was okay. But then when you say, I'm going to report the state about this, you have to tell it this light bulb is off or on, is in this color, in this brightness. You need to tell it about all the traits. So just to finish real quick, and then we have questions. A couple of tips: don't deploy all the time. Don't put this in a cloud function and keep changing stuff and deploying it. Don't put it in a server we have to deploy. Do it locally. Use a local tunnel like in Grok or local tunnel, although local tunnel is being kind of sketchy lately, so keep that in mind. If you pay in Grok, and it used to be free with local tunnel, you could use a specific subdomain. So you could just go to the Google Console API, Google Actions API, Google Actions Console, and change the URL once. And every time you open your tunnel, it has the same URL. You don't have to change it anymore. Again, log everything. I just went to the log screen back and I saw, oh, Google is asking me for this. This is what I'm replying. That is really easy to debug. That's a really good practice that you should follow. And sometimes things are going to go wrong. For example, here I did something and now I said not responding. And in order to debug this, you have a couple of tools. Your logs, the ones that you output, Google is not going to help you with that. And then you have to validate your responses. Those responses for all the traits and all the values that the devices can have, you might accidentally get them wrong. So there's a validator that you can go right here, and you can paste your JSON and click that button, and right there you get that little indication, oh, this is fine. It's not the best thing, but it does the job. And also you can check the logs. In my case, I get, every once in a while, Google gets a little bit mad at me and starts throwing authentication errors with OAuth, and I guess it's just, the token expired and it didn't bother to renew. So that happens a lot. Check these logs. You have those available. Just make sure that you filter by the type that you're looking for Google Action, and you can find them really easily. And again, this is really easy to test. You don't have to go crazy and do unit tests on this on your API. You can actually just test it on an API level. This is just Postman. I have a couple of requests in there and a couple of tests. And this one, for example, is testing that if I ask for the login endpoint, I'm actually redirected to somewhere else, which is what I want with the API. And with that, I'm done. This is time for questions if you have any. Thank you.
Any questions?
You can also ask in Spanish, so I'll translate. It's fine. I was right on time.
Don't worry. So I have actually two questions. The first one is, don't worry. So is there any way to, in the way back, to update the status to the current state to Google, is there any way to say more than is okay or is not? I mean, if your light bulb cannot set the brightness to 95 because it's 10, the step is 10.
Yeah.
I mean, can
Yeah,
you say that as well?
Yeah, you can tell that there's an error. You can just tell error, and Google will reply to the user, something went wrong. But probably that means that you didn't set up your limits or the values or the attributes in the way you're doing your business logic. It's allowing that value to go through, which in any case, like, and in the code that I have in Arduino, for example, I'm just using constraint. If you ever use Arduino, like, my values for RGB can go from 0 to 255. If you send me anything, like, it's gonna be bound to those things. So it shouldn't happen. But you can tell Google something went wrong. You can tell it something went wrong. There's an error, and they can retry. And you can actually output logs in your API that you can actually go back later and see, oh, I don't know, something happened here, like that value was out of range or whatever. Yeah, you can tell it.
Okay, can I ask you the second question? Okay, so the normal workflow is that you talk to Google and Google commands to your IoT project. Is there any way to, the initiator of that workflow is the IoT project, and then just to...
Yeah, I mean, for the stuff that you can do proactively, like report the state of a specific device, the flow starts on your side. Like, if I touch the light switch and I change the state, you are starting the process and sending a report state to Google, telling the Google, well, the smart home API, hey, this thing changed. So in that case, you are the one starting the flow. But for all the other stuff, the user needs to start the interaction, either through the screen or through voice. Thank you.
Thanks very much for your talk. I have two questions. The first one is, how much would it cost to build this system from scratch, provided that you have a computer? And how long would it take to build for a user with technical background but without too much experience with
You're
IoT?
asking about building specifically this?
Yeah, without the Lego.
So we had a workshop, and I'm going to use this as a segue. We have another workshop as part of another event in Jeddah in the next month. And the workshop, it takes around 3-4 hours to go through the code and make sure that you understand everything and everything is running on your computer. But we have a workshop when we plan on doing that in other places. So it takes like 3-4 hours. If you're experienced, it can take you like an hour, maybe 2 hours. So, and as far as the cost, we made kits and we give them away for free to people that come to the workshop. So if you're close to Jeddah, you know, take a look at this. And they're around $7 for everything, like the LED plus the breadboard plus the cables plus whatever we use, even like a small cardboard box that we did. So it's really, really cheap. I'm gonna take this moment to tell you guys about, there's an event happening next month in Jeddah. It's an event aimed at people with reduced mobility. We're doing a hackathon, which is not exactly a hackathon, it's more of a contest. And you can create actions that are specifically aimed at solving problems that people with reduced mobilities have. So we're gonna have one of these workshops on the 26th in Jeddah, and on the 27th, we're gonna have like a little bit of a contest and judge all the submissions. And you can submit, you know, whatever you think is going to be useful. There's a couple of requirements. Check the website. It mainly needs to be in Spanish, at least. It can be in other languages. So yeah, there are prizes. So, you know, go for it. You don't have to be physically there to win. So if you submit something and you get selected as a winner, we'll ship it to you. And this was organized by our friends at GDG Jeddah. Again, GDG does a lot of things. Yeah, they're really cool, especially Andreu. Hi, Andreu, you rock. So feel free to participate. And if you're around, you're free to come to a workshop. It's free.
Okay, so first, thank you so much for the talk. It was
for
great
coming.
and very well organized and everything. And I have just one question. It's super fast. My question is, like, when you receive the data for the device, do you store it in the internal memory of the phone or of the device, or you just like read it every time from Firebase directly?
Well, it
I mean-
really depends on what kind of strategy you want to do. Like, for example, here, that's not even stored anywhere. It's just in memory. If I stop the server, I won't know about the device anymore. So again, it's up to you. It's up to your implementation. If you're storing this in Firebase, since it needs to be live data and it can be modified into different places, like I could have a Firebase client in this device, and I could have a switch, react to the switch, write a value on Firebase, and I don't need HTTP. Firebase will write that change to the database, and whoever is listening on that Firebase database, it can be a cloud action that's reacting to writes on the database. I can react to that and do something else. And the other way around, somebody can issue a command through Google or touching the screen and write another, end up writing another value in Firebase, and that needs to propagate to the device. So you're not really reading it. If you're using Firebase specifically, you are observing changes in that. So you get one value initially when you connect, and then you get updates on that value. So it shouldn't be crazy. You should, as long as you have like a kind of stable internet connection, you don't need to keep reading. You can just wait for Firebase to tell you, for the client library to tell you, oh, there's a new value for the color or the power if you need to be on or off. So you don't really need to read it, you react if you're using the real-time Firebase database.
Vale, pues muchas gracias a todos por venir y nos vemos.